Good morning, everyone. Thanks for joining us. Who in here had used a transcription service to transcribe their video or audio assets in the past? Raise your hand, please. Thank you. Who in here had never used a transcription service but plans on using it in the future? Awesome. Welcome. We have some great content for everyone. Today we will be discussing how you can transcribe your media assets using single-click frameworks. My name is Raju Penmacha, and I work as a senior AI/ML specialist SA at AWS. Joined with me is Andrew.
Yes, good morning. I'm Andrew Kane. I'm our worldwide tech lead for AI language services, and I'm coming in from the UK. So today, Raju and I will cover a number of different topics covering Amazon Transcribe. So I'll start by talking about the value that you can hopefully unlock from your audio and video files, what could actually help your business by knowing what's in those audio streams. How will it actually benefit you as an organization? I'll then move on to some of the underlying features of Transcribe, what it will actually do for you, and all the different services that it provides, and talk a little bit about what our customers are currently using Transcribe for. I'll then pass it back to Raju, who will then talk about, excuse me, why you may have a need to actually customize the output of Amazon Transcribe to make it more suited towards your domain or your particular context. He'll then talk about something called our single-click framework, which is an application that we've been developing that will not only help you build a custom Amazon Transcribe language model, but it'll also give you a mechanism to let it help self-heal and actually improve itself over time with minimal intervention from you. So we do have quite a lot to cover. So the main question really we want to answer here is, are you capturing value from your audio file or your audio streams? The answer is probably, no, I'm not. And that's what we get from most of our customers. And this is where technologies such as Amazon Transcribe can come in to actually do this for you and actually get that value out of the streams. Because data in audio or video form is virtually impossible for any computer to actually search and analyze. So it has to be converted to text first before you can send it to perform any other downstream tasks, such as subtitling, translation, and other things like that. Now, you can unlock the value of your audio by using human transcription, but traditional transcription methods are slow, they're quite expensive, and they don't scale very easily, because to scale a transcription service manned by humans, you need more people. And that's very hard to do in an on-demand basis, where you have to do 1,000 files tomorrow that you weren't planning on doing. So it's also quite expensive. And you also find, what I have found, that no two human transcribers will actually transcribe the same audio file in exactly the same way. So it's not necessarily consistent from file to file, from person to person. So unless you can have some form of automation in your speech-to-text processes, you can't really hope to transcribe the entirety of your video libraries or transcribe every call coming into your contact center. You just won't be able to do it. So really, there has to be a better way of achieving this. So this is where Amazon Transcribe comes in to solve these problems. Firstly, it's an automatic speech-to-text service that uses deep learning and AI for speech recognition. It really leaves you to worry about your business because the service itself is fully managed and fully trained by AWS. We're spending all the time and effort to manage and maintain and update multiple language models across the globe in different languages or different dialects of different languages, leaving you to focus on what does your business actually have to do. So it replaces the costly process of manual transcription, because you just don't need to do it. You'll get a highly accurate, efficient, and consistent transcription output each time you put in files through the system. Now, in addition to, in addition to all the on-demand content, we notice increasing the accessibility to like streaming data is really, really important. And so to get the value out of those streamed audio files, you have to get the answers for the transcription really quick. We're talking a second, 2 seconds, 5 seconds. You can't wait for a day to get this live stream transcription. And so our APIs are really very, they're very fast, they're very responsive, and we make sure you can do these transcripts in real time if that suits your use case. And we try and make it very, very easy to adopt by most of our customers. To start transcription jobs on like an audio file that's been pre-recorded, it's one API call that any developer can make with no knowledge of AI or ML. And within a few minutes, the transcription of your 1-hour video will be available. It actually is quite simple to use. So converting audio and video into text actually improves your business outcomes in lots of different ways. The first, it really unlocks the value of the audio and video because it makes it discoverable, it makes it searchable. So it's really important for organizations where this content library is getting bigger and bigger by the day. So as more and more audio and video content comes in, as your video library increases, as more contact center calls come in, as more educational content gets created, more medical interactions happen in the hospital, and more legal files come in from sort of law organizations that need transcriptions instantly. These are growing by the day. So having an automatic system like Transcribe do the transcriptions for you means you can do it without particularly worrying about any kind of time constraints. It can also increase engagement with your systems. The obvious examples of things like click-through rate, time spent on a website, perhaps downloading artifacts, and things like that. By providing automatic subtitles and even translated subtitles for audio and video content does mean that customers will actually engage with your platforms more. Which again, if you have that customer retention, that makes things better for you because you're increasing the potential revenue generation opportunities. And actually makes you stand out more within a very crowded digital marketplace or digital environment. And also allows you, the staff and organization to become more efficient. Good examples are a physician who can actually search through their previous interaction notes, the previous medical notes with a customer, with a patient who is in front of them at that time. And contact center agents who are on a call with someone who's a particularly difficult customer, they can actually search transcripts of this customer for previous calls while they're still talking to that particular person. And they don't actually have to lose focus by looking up some previous information. So this makes them more efficient, which hopefully in turn makes the revenue generating opportunities of them much more, hopefully much higher. So it works by transcribing the real-time audio or audio streams or pre-recorded media content. And so for real-time transcriptions, you create a connection using something called the HTTP2 or WebSocket protocol. You stream audio into AWS, and in return, it will stream transcripts or partial transcripts, as each word is said, back to you as a live stream. So with batch processing, it's much simpler. You deliver an audio file, and Amazon Transcribe will pick up the file, process it, and within a few minutes, it will deliver back the transcript. It's much simpler in that sense. There's less moving parts, and there's less complexity. Now, irrespective of the mode of transcribe you actually use, whether it's batch or real-time, you basically get the same core features to you across the platform. Now, batch jobs, as you can imagine, they have enough time on their hands to listen to the audio faster than it's actually spoken, and they have time to go back, replay the audio, double-check things, perhaps change some errors that it may be making on the way, and give you a much higher level accuracy transcript. And you'll find it's probably just 1 or 2 percentage points better than the live stream in terms of accuracy and confidence factors, because quite simply, live transcription hasn't got the time. You're talking to it in real time, and within a few seconds of finishing a sentence, you want the transcript. So it hasn't got enough time to go back like batch has and correct every potential mistake. It's very, very close, but you will find that batch is that little bit more accurate than the streaming use case. Because what you don't want to do is, doing a live subtitling streaming session, you don't want for the subtitles to appear after the action on the screen's actually been and gone. It has to respond within a few seconds. You have to have the words out there. So that's just worth bearing in mind when you do it. So I've got a rich feature set. We're going to go through a few of them quite nicely, quite quickly now, and they help you produce accurate and consistent transcripts across the board. So these can come complete with punctuation, word level timestamps, word level confidence scores. We can identify the speaker, we can identify the channel. So these things are automatic as part of the service. They're there always, and you can never actually turn them off, which means if you've got a labeling or subtitling job, having this information such as the timestamps per word makes alignment of the subtitles with the screen action much more powerful. And it means you can actually make it more accurate when you're playing these things back. The word level confidence scores, they're actually there to say this is how confident Transcribe is that this word is correct. This is taking into account all the factors such as pronunciation, mispronunciation, speaker accents, dialects, background noise, and the person just mumbling and mispronouncing things by accident because we're only human. So what that will do is give you an indication of actually you may want to go and review the transcript again, review the audio with a human-in-the-loop workflow kind of process, and say, actually, this word, it was correct after all. It was just noisy background noise, but Transcribe got the right result. Sometimes it might be wrong, and the human-in-the-loop workflow can come in play and just correct that word, and you can then carry on. Language ID is quite key. It lets you handle incoming media or incoming streams where you don't actually know what the language is. And then in the EU, I've definitely got some customers where one of them actually has to transcribe audio from every member state. And as there's 27 member states, that's a lot of different languages. And they don't know which one it is until it comes in. But just by putting the audio file through transcribe, it will tell you quite quickly, this is German, French, Spanish, Danish, whatever it happens to be. And transcribe will pick the right language model and transcribe it in French, German, Danish, Italian, whatever it happens to be. But more than that, it can also distinguish between different dialects of the same language. So as well as saying this is English, not French, it can actually say this is US English, GB English, or Scottish English, which is really useful for customers who live in and work in a multi-English area, such as I do in the UK, which is why we have models for Welsh, Irish, Scottish, and English. And so being able to pick the right language and pick the right dialect just improves the accuracy overall of the output transcript. So we have a few features to actually help you boost the accuracy of the transcriptions. So you can customize the whole service to be more tuned to the word within your domain. So custom vocabularies, what this will actually do, it will let you, excuse me, add a list of words that are important to you and your organization, but it also lets you add things like pronunciation hints using phonetics to say this word should be pronounced like that. For common words in the language, it doesn't really matter, it's not that important, but if you have custom names, custom brand names, words that don't have a necessarily obvious English pronunciation, it's quite useful to have the phonetic side to make sure that transcribe can absolutely nail this customized word. When it comes to products and brand names, this is quite common because most products and brand names are not necessarily real words. They're made up by marketing teams, of course, and they may have customized case, they may have mixed case, upper and lower case, they may have hyphens or periods in the name. And so we can all use transcribe to tell it, when you see this word, actually, can you output it like this? Put the periods here, the dashes there, change the case like that. And you can make it actually not just recognize the word, but output it in a way that suits you. One thing that's also useful is phonetic mispronunciation, which is something most customers don't think about, is that some people consistently mispronounce the same things over and over again. So what you can do with transcribe as well is you can target one of these mispronunciations and say, when this person says this, actually transcribe it as that. This is quite common in environments such as sports broadcasting and sports commentary, where the commentator may mispronounce a sportsman or sportswoman's name because it's not in their language. But they consistently mispronounce it over and over again, week on week. And you can teach transcribe the correct pronunciation for those names and the incorrect pronunciation. So it knows when you say a certain word, it can map it to the right name. And that's a really powerful use of this, which most customers tend to miss out on. The custom language models, I think Raju is going to talk more about that later. That's really where you augment the base language model. So you take US English, and you add to it all of your own marketing materials, training manuals, your website data, information from your own previous existing call transcripts. And you tell transcribe, build me another English model that is yours plus all of my extra data. And it will. And that lives within your AWS account. No one else sees it. No one else has access to it. It's your customized domain-specific language model. And that you'll see the word confidence scores increase by 10, 12, 15% sometimes, depending on the niche of the use case. And it really, really personalizes it for you and your organization. The last thing is alternate transcriptions. We can give you up to 10 alternates for a particular phrase in the transcript. Now, you don't always get these, but when you do, it's because there's like really serious background noise or background issues. We give you confidence scores as normal, but with the alternates, what you've actually said is, if you've said this and we have a few low confidence words in it, actually, if you change the model settings, it should have been this phrase. And if that sentence was actually this, and the follow-on sentence should have been that. But usually you don't get them. But when you do, what customers can do with these is they send those sentences immediately to their human-in-the-loop workflow that says, it was that one and that one, carry on. Because some situations when it's very noisy backgrounds, transcribe will do its best to get it correct, but when there's alternate options, we will tell you, and if you have a human-in-the-loop workflow that's there to generate subtitles, it's a really quick process, and we have this in play as an example for some sports organizations doing sort of live broadcasting, live transcription of sports events. It's a really simple human-in-the-loop workflow that just says yes or no to these particular variations, and it works really well. Lastly, user privacy and safety is very, very important for everything we do. So we have vocabulary filtering in play in transcribe, and we also have the ability to redact personally identifiable information. So when transcribing audio, you can instruct transcribe to basically automatically mask, completely remove, or just tag for reference, anything that's in a vocabulary file that you provide. So most customers will use this with things like profanity filtering to make sure that particular words or hate speech does not get into the transcript. They're taken out at source. But other customers will actually use it for things like, I've got a vocabulary filter of project names or product names that are in development, so they're meant to be secret. So though meetings are there, meetings are getting transcribed, everyone's talking about these wonderful new projects, We don't want a record of them in the transcriptions, which goes into a database which anyone can then search. So we make sure the project names are removed as well from the transcriptions. Secondly, with the PII redaction, there's multiple categories. They're all documented on the website, but this includes things like account names. So your bank routing code, account numbers, credit card numbers, CVV codes, PINs, social security numbers, names, addresses, emails. There's quite a large list. And by default, we transcribe everything we hear. But you can option tell transcribe to say, actually, take out the bank details, take out the credit cards and PINs, leave the address, that's fine. So it's all under your control. So these things will get removed, and you just get a sort of blank mark in the transcript that says there was something here, a PII word was found, but we're not telling you what it is. And once that's gone, it's gone. But what you can also do if you use the call analytics feature of transcribe is, we'll take the audio file that we ingested in the first place, and where there was PII, we'll blank out those words in the audio and give it back to you. So not only do you get a PII redacted transcript, you get a PII redacted audio file, which you can then put into your playback systems. So even supervisors later playing back the audio can't get the PIN codes or the credit card numbers. What do you support? Lots of different audio formats. So we work with 16 kilohertz audio and above, so the level of quality that you expect for broadcast media. That's what we actually handle normally. But you have additional models that are tuned towards the much lower quality audio that you get in telephony systems. So we can handle 8 kilohertz audio. And those streams are quite poor quality, as you'd expect. So that's why I have different models for the 8 and the 16 and above. And it means you can have very accurate transcriptions of those lower quality calls. And some of the television systems out there are actually really poor, especially if they're old. The sounds are quite terrible. But Transcribe is designed to actually handle those scenarios. We integrate with many different AWS services. Amazon S3 is the obvious one because that's where the audio files go and where the transcripts end up in if you're doing batch mode. But we can connect to things like CloudWatch and CloudTrail to make sure we're logging what's happening, who's using the service. We can use EventBridge if you want to have actions taken when something finishes, like your transcription job is now finished, go get the transcripts, or something along those lines, or it's failed for some reason, or a new custom vocabulary is just being created, you can now use it in your systems. EventBridge is great for that. And of course, the step functions, our workflow orchestration system, you can use that to actually start transcription jobs within the workflow without writing any code. And so there's lots of ways to integrate Transcribe with our services. What do people do with it? Lots of things. So we have a few icons on screen, but we can only talk about one or two of them really right now. So if you have anyone interested in the other ones, please just talk to us afterwards or ask questions when we finish the session. So Call Analytics and Agent Assist in the contact center is quite a big application these days. We had a session yesterday on CCI, which is well attended, and it's a really big growth area for the transcription services, because this can actually unlock insights using real-time or post-call analytics on the telephone call to let you understand the voice of the customer. And it also lets your agents do things like improve their performance and actually better handle a call that's in progress using something called Agent Assist. Now, this is where we have something in the background which can actually push up suggestions to your agent to say, give the customer this information now. Because as the transcript comes down, we will say, or you'll spot the customer saying, I want to close my account. Alarm bells will go off somewhere. And then that system could pass that line down to another backend system that says, what is the best offer of the day to stop customer churn? That can get sent back to the contact center agent who's still chatting to the customer, and they can see on the screen instantly, offer them 6 months free, 3 months free, $25 discount, whatever it happens to be. So all these agent assist technologies can kick in and really help out the agent just because we have live transcriptions in play. If you didn't, these things just don't work. Second one really is search and discovery. Whenever you have audio data, podcast data, or videos, this really allows you to build up a very large, rich metadata index of the spoken word. And so you can always see what topics are being discussed, and when, how often, how frequently, and you can make that available for search. So if you're looking for, I need a video where we're talking about X, Y, and Z and has these topics discussed, you quickly get back a list of the last 10 videos you ingested that had these things in because it's in the transcripts. And taking that one step further, if you look at chat moderation or UGC, this is really exploding in gaming chat rooms these days, as well as talk radio, social media, and other such environments. And Transcribe can be there, and live, before these live transcripts get put on the screen, we can do the content moderation to remove, as before, we mentioned the hate speech, we mentioned profanity, and that can get taken out straight away before things get translated into multiple languages. So in those environments, we find that it's actually really powerful to have Transcribe in play. So we have a number of reference customers, and they're all available on the website on AWS. But I thought I'd talk just about 2 or 3 before handing over to Raju of customers that use these technologies really well. So one is Echo 360. They provide a sort of video platform technology that helps instructors and students record, stream, manage, and otherwise interact with video content, and hopefully improves their participation within the actual courses they're studying. So Transcribe lets them do smarter search. It gives them better ways of actually engaging with the content, and actually gives colleges and universities a pathway to actually easily and affordably record and transcribe every educational session they're actually running across the course of that semester. And these transcripts are then automatically uploaded to the Echo 360 platform, so anyone can search them and anyone can use them. But more importantly, when people are using them and looking at them afterwards, it gives the instructors access to metadata they just never had before. So they can now see at a glance who's looking at the videos, how far are they getting through them, are they having particular problems, which languages are important. And when they see students are having problems, they're not getting through the videos fast enough, they can proactively reach out to help those students before the test, rather than after the test, which is far too late. So they're using Transcribe for that to really just make student engagement much better. Maximus, they're a pure play provider of government health and human services programs, such as Medicaid, Medicare, that kind of thing. And they work with one of our partners, Success KPI, to actually give insights in terms of contact center analytics. So they work with a partner to handle thousands of agents with millions of calls over a month, which is what they're doing all the time, and actually trying to give insights of what's going on to actually deliver information on the voice of the customer. This was despite the fact that their telephony system was on premises. It wasn't actually in the cloud, but they could still take advantage of AWS AI services like Amazon Transcribe, Amazon Comprehend, and even Amazon Translate, and use Success KPI's platform to actually give them things like quality management, automatic reporting, and also give a view on how well is the agent actually performing in terms of handling the customer. Have they got a good outcome? Is the customer happy or sad in terms of sentiment? And that also lets you get a view on how compliance-oriented is the agent. Are they actually saying all the right things they have to say for legal and compliance issues, which is really important when Maximus is dealing with government agencies. And the last one is NASCAR. They actually sanction more than about 1,200 races now across 30 states, across the USA, Mexico, Canada, and Europe. And they publish about, well, probably hundreds now of short-form videos every single month. And they wanted a system that would put captions on all of this content, all of their video-on-demand content. And they chose Transcribe. Now, they chose it with one eye in the future, because although the use case was batch, it was offline, pre-recorded, after-the-fact video subtitling, they wanted something that would, in the future, using the same mechanisms, using the same tooling, using the same custom vocabulary for languages, using the same technical nomenclature that they're used to in racing, they wanted it to also do live streams, and that's the way they're moving towards it now. And so they only have to have one tool. They're just using it in two different ways now to handle all of their content. And so I think they now closed caption 99% of the video-on-demand content, and they were quite surprised to find it cost them about 97% less than they actually expected to pay in the first place to do such a transcription system. So that's Transcribe at the high level of everything that it actually does, everything it covers, everything it can do. So can I hand it back to Raju, who's going to talk about how to do that custom language model piece and how to get a language model built to your use case that will actually self-learn and heal itself when it feels it's no longer as accurate as it could be. Thank you.
Thanks, Andrew. So far, you have learned how transcribing your audio and video assets using Amazon Transcribe can give you immediate business value. Let us now discuss what some customer concerns are when transcribing. We took audio files from 3 different domains: biology, physiology, and organic chemistry, and transcribed them. The words that you see in green are from human transcriptions, also referred as ground truth, and the words in pink are transcription outputs. The word prokaryotic cells was transcribed incorrectly as prokaryotic cells. Flagella was transcribed as flugella, microfibrils as microfibers, endotendinium as endotendin-iam, and so on. Please note that biology, physiology, and organic chemistry are, in general, difficult domains to transcribe as they carry special words. Here is a complete sentence from the biology audio. On the left, you see human transcription. On the right is the output from Amazon Transcribe. As you can see, domain words such as ribosomes, organelles, cytoplasm were correctly transcribed by Amazon Transcribe, but it missed the word endoplasmic reticulum. This is a full sentence from the organic chemistry example, and the word saponification was mistranscribed. Custom language models, CLM in short, can help you build custom models that are specific to your domain. Amazon Transcribe offers CLM out of the box. You can train as well as create transcriptions out of a CLM from AWS console through using its SDK or from the command line interface. You can train a CLM using domain-specific text, such as website content, training manuals, technical documentation, and any audio transcripts that you have. Transcribe offers you two levers when it comes to training and tuning a CLM. You can use your domain text to train the model and any available human transcriptions to fine-tune the model. After running a custom language model on biology, this is the output. As you can notice, the word endoplasmic reticulum is correctly transcribed this time around. And a different CLM model was trained for organic chemistry using its domain text, and the word saponification is also correctly transcribed this time. As you saw, a custom language model can help you transcribe your words correctly and and it's a good capability to have. Having said that, there are a few areas where a CLM can do even better. For example, you cannot tell upfront if a CLM will improve the output for your audio files. It requires you to bring your own training data. What if you don't have any training data? You need to find an external library to calculate word error rates, a useful metric to evaluate your transcription outputs. You also need to write some code if you want to figure which words were missed and to automate the entire CLM workflow. A single-click CLM framework that I will show you now will take care of those needs. The way it works is it requires two mandatory inputs from you, one optional input, and you click a button. It is that simple. You need to fill a configuration file. You will supply a couple of audio files with human transcriptions. Optionally, you can also supply a list of keywords that are specific to your domain. Behind the scenes, this framework will download training data from Wikipedia. It will read your input files. It will run Amazon Transcribe, runs a CLM if one is available. It will normalize the output, calculates word error rates, saves the results such as missed words, other metadata. It will also create a model leaderboard. If the self-heal option is turned on, it will first evaluate which words were missed by the past runs. After that, it will download Wikipedia training data based on those missed words and then build a new CLM model. This way, it's trying to learn from its own mistakes. In addition, you can run this framework any number of times. The model leaderboard will sort all the models and keep the most accurate model at the top. Let us take a deeper dive. The configuration file is really simple. It expects you to supply it the name of your S3 bucket, a bucket prefix, which is a folder under your bucket, whether you want the self-heal option turned on, and an IAM role with required permissions. Here is a sample list of keywords for the biology domain. As you can see, these are all words from biology. And here is a sample list of keywords from organic chemistry. This framework goes to Wikipedia for each keyword that you had supplied and tries to download data if it exists. This is a sample Wikipedia page for the keyword abdomen. You're expected to supply a couple of audio files for this model, and the format is as follows. You need to require a folder named input under your bucket prefix. Under the input folder, you create subfolders for each unique audio file that you have. Within that subfolder, as you can see, you will place your audio file and its corresponding human transcription. Here are the results from running this single-click CLM framework on biology audio files. I ran it on 3 audio files. For audio file 1, the word error rate from Amazon Transcribe is 11.7%, and the word error rate coming out of this framework was 5.7%. The lower the error rate, the better. So it saw a 51% relative improvement. For audio file 2, the improvement was 13%, and for audio file 3, 18%. At the bottom of the slide, you can see words that were fixed by this framework. For organic chemistry, I ran this framework against 2 audio files. For the first file, the improvement was 20%. For the second file, it was 7%. When I turned the self-heal option on for audio file 2, it tried learning from its past mistakes, and the results were improved by 33%. So this shows the power of self-healing. So some advantages of a single-click framework are as follows. You can easily build a CLM model without writing a single line of code. You can check if CLM makes a difference for your domain or not. You don't have to supply any training data, but you have some training data, it will take it. You can learn which words were missed by standard transcribe and which words were fixed by the CLM. And the advantages of a self-healing CLM framework is it can fix its own errors, as you saw. You can run it multiple times, and you can automate the CLM retraining itself. Now we will see a 4-minute demo of this framework in action. Amazon Transcribe helps you transcribe audio and video files. For domains such as biology, organic chemistry, physiology, and so on, that carry very specific vocabulary, Transcribe offers a service called Custom Language Models, CLM in short, to accurately transcribe those domain-specific words. Let's play a small audio snippet.
Meiosis produces the gametes that then random fertilization is going to produce the genetic diversity, which hopefully you're like, why do we care?
We ran this biology-related audio through standard Amazon Transcribe and through a CLM. Results are as follows. Ground truth is human transcription. As you can see, Amazon Transcribe missed words like meiosis and gametes, while a CLM had correctly transcribed them. From AWS console, you can go to Amazon Transcribe. From here, you can either run a standard transcription service or even a custom language model. You supply your domain-specific data as training data to CLM. Alternatively, you can also run them using the SDK or command line interface. Single-click framework goes beyond what is offered in Amazon Transcribe today. It lets you figure whether CLM makes a difference or not find which words were mistranscribed by standard transcribe, as well as self-heal itself. This framework will soon be released to the AWS Samples GitHub repo. This framework requires two simple inputs. First is the config file, where you specify your bucket and the prefix. Self-heal option, when turned on, downloads training data from Wikipedia based on keywords and missed words from past runs. You also specify an IAM role. Second input is under your bucket, where you create a folder under your prefix named as input. Under input, you create subfolders for each audio file that you have. Currently, I have one folder with an audio file and its corresponding ground truth. Now, I will run this framework from SageMaker Notebook. You can also run it from your own laptop. Once it completes, we get two outputs under results folder in your bucket prefix. Let's download and examine them. This is the runs.csv file. ST is standard transcribe. WER is word error rate, the opposite of accuracy. The lower the better. You also see the words that are missed by transcribe. The actual audio file is longer than this small snippet you heard earlier. I made few more runs by turning the self-heal option on and adding more folders to my input folder in the S3 bucket. Let us examine those results. The runs.csv file this time shows results from all the CLM models and standard transcribe. You can examine them and see how each of these models performed against each input file, which words were corrected, and so on. Each folder here represents a unique audio file. Lower the WER, the better. As you can see, although CLM model did better than standard transcribe on most audio files, standard transcribe didn't perform too badly. This framework also creates a model leaderboard with all of your models sorted based on WER. You can use the model at the top of the leaderboard for transcribing your future audio files.
That's the end of that demo video. So in conclusion, Amazon Transcribe helps you derive value out of your audio assets. And for domains where the words are tough to transcribe, because they're very special words, you can use a custom language model. And the single-click framework that you saw today makes it even easier to use a CLM. While you are here at this summit, we would like for you to be engaged with AWS skills training and certifications. Please scan one or both of the QR codes to get more details. We offer 11 AWS certifications for both foundational, professional, and specialty areas, and these can help you increase your confidence and credibility with industry-recognized certificates. Thanks for your time with us today. If you have any questions on this single-click framework, we'll be happy to answer after this presentation. And for those of you that are interested in getting any help with this framework, once it is released very soon to AWS Samples GitHub, we'll be happy to take your contacts and contact you. But other than that, thanks again for your time with us today. Thank you. Please take the session survey to give your feedback. Any questions? Yes.
Thank you. So I saw that there are two options to improve the transcription quality, the custom vocabulary and custom language model. Are they completely orthogonal, or do they kind of depend on each other? Can I use custom language model without the custom vocabulary? And no.
Okay, so they are for completely different use cases. So The custom vocabulary is there to really correct the pronunciations for specific words that you're trying to target or to alter the output of the transcriptions. CLM is adding more and more context-sensitive content so that we see these words being used in more context. So the biology example is by seeing the words endoplasmic reticulum, it's got no chance. But once you give it a CLM model with some documents to talk about these things in context, it will add that to its language model and realize, that's what those phonetic sounds meant. But you can mix them together. So the CV might give you up to, say, 3 or 4% improvement in the confidence scores, and CLM will be much higher. But with the CLM, it takes a lot more work. CVs can take you an hour to get something working. CLM takes a bit longer, but the improvements are much, much bigger. However, in the CLM, you might still have those strange words that haven't got really good pronunciation, so you can add a custom vocabulary to the CLM and actually have both in play together. We tend to tell customers, if you're having issues with accuracy, start with custom vocabulary first because it's quick, it's simple to get some really simple results. But if it's a more specialized domain, such as the educational domains for sciences, CLM is more likely the better option to go for with custom vocabs as just pronunciation hints for things. But yet use one or the other or both.
Thank you.
Hi, Brandon Kopp from the Bureau of Labor Statistics. I have a sort of maybe a niche question about sometimes when we do our research and we want to transcribe audio, the sort of fidelity of the actual audio is very important in terms of like not correcting too much mispronunciations or screening out ums and ahs and things like that. Those are important. Does this do that, or does it accurately sort of transcribe all of the disfluencies and things like that?
Yeah, so transcribe will actually transcribe everything that it hears. If you say and are, we will transcribe them generally. We do have customers who have got legal requirements to record everything. So even if it's just filler words like we will put them in there. Now the options you have here are things like the vocabulary filter. If you just don't want them there, you can put them in to say, just don't have and ah. It's quite simple, they'll be taken out of the transcript. But we do put them all in. Sometimes also in custom vocabularies, though, we see customers say a word that's been incorrectly transcribed, and it may just be this background noise, a real mispronunciation by the person, and they add that word to custom vocabulary. And we try and say, please don't do that if it's a standard language word. So if it's like the cat sat on a mat and mat doesn't come out properly, please don't add it. It's a standard word. It should work unless there's background noise situations. And so we try to say, keep it for your domain words, keep it for nouns, keep it for entities. That's the best thing to use it for. Otherwise, you're overcorrecting the model and you're overtraining it on simplistic words that are just part of the standard model. So it really works better on your own words. I think the sports example I mentioned is quite common in that people do mispronounce things a lot, so just put them in, even though it may be a standard word. It may be the speaker on this particular show or this particular sports program just keeps mispronouncing it, so you have to put it in. So there may be needs to do it, but generally stick to your domain words, stick to your nouns, and don't try and overcompensate for background noise.
And one small trick that I played was in the framework that I've shown, there is this step called normalize the output, and I had explicitly asked it to remove those ahs and ums because some of them are pretty common that you can capture them, with specific programming.
And I guess that prompted another question about the range of audio quality that it can handle. Is there sort of I'm just curious about the sort of range of audio quality it can handle versus, if we have laptops recording, from across a dining room table versus actual setup with microphones and things, how does it do?
It can make a big difference, of course. If you've got a single directional mic, if it's a mic right in front of you, it's going to work quite well because it's going to just get your sounds. If it's a mic over there by that speaker and I'm over here talking, as I just turn my head, you're going to get a direction of the sounds going the wrong way. It's going to pick up less audio. And so it's just going to be quieter and quieter. And there isn't much you can do about that, unfortunately. One thing we do say, though, is the Amazon Transcribe models, they're actually trained on really good quality data and really poor quality audio data as well. So we do ask customers to try not to overcompensate. Don't go in there with tools like FFmpeg and just try and augment the audio and make it louder or do noise reduction, because you can actually take away the very things we're looking for in the audio. So we're used to coping with that. When you get a situation like that where you actually can't hear it at all, and the decibel levels drop down to 10 or something through the floor, where you just can't hear it. In those situations, you think you've got no choice, but at least get it up to a minimum level where it can be picked up. But we try and say, just leave it as it is normally. Don't try and do too much signal processing on the input audio. because we do train for good and bad.
Thank you.
Just one more thing to add to that is there are also, even though that doesn't answer your like far field communication, the speaker is far from the speaker and things like that. Transcribe does offer multiple dialects, and I've seen customers where, within English there are, I don't know, like 6 or 7 dialects, including Australian English, in addition to the British English and US English and Indian English and things like that. And sometimes that experimentation also can help you in improving your transcription output.
Yeah.
Monty McGee, CRI. I just wanted to pick up on that, the point you made about the background noise. I was really interested in the call center use case. And so in environments where multiple languages are being spoken, can you just talk about the error rate and how that was adjusted for? And then also in terms of background that is essentially music, right? Where you have, an individual speaking, but then you also have sound kind of kind of intermixed. Can you talk about what that actually did in terms of the use case?
Okay, so the first one I think is when you have a mixed dialect speaker, so Indian English talking to Scottish English, say on a telephone call.
Multiple languages being
okay.
in a call center.
So right now what happens is the language ID feature will pick the dominant language that's going on in that particular audio file or the audio stream. So if it thinks the dominant language is US English, that's what it's going to do for the entire audio stream. So it's been requested by many customers, though, in the past that we want to have channel by channel or speaker by speaker, or even paragraph by paragraph language ID. So that's going to be the service team. It's being considered for a feature release sometime in the future. So it's an active development effort in that area. So that's something that will get better over time, and the models get increased or improved. But right now it is one language per file in the end that we can only do. But it will get better over the course of time.
If I can, quickly add something. I've seen some communication where, again, I don't know if this will work or not, Andrew, which is, let's say there are a couple of languages that people are speaking, and you can, Transcribe has this feature, like Andrew was saying, that it can identify the language, or it will ask you to input the language, right? And I've seen some communication where they ran it, let's say you have 2 languages, they ran it twice. Once with the first language, again with the second language, and then do some, some kind of mixing. So these are also some experiments that you can probably try.
Okay. On the background noise, so Transcribe is designed for the spoken word. It's designed for conversation, whether that's just on broadcast TV or whether it's on radio or telephone call. So it's designed for that. It's not designed to transcribe singing. So if you have music playing and you have someone singing, that's not going to work at all. It's just not a good fit for the use case because they're not singing English or normal English words. They're making very different pitches, very different inflections, making syllables last 10 times longer than they should. So it can't do that. If you have background noise, though, the transcription tends to work quite well. What you find that sometimes an error is the start time for the word. So if you've got music playing, we're actually listening to it in Transcribe. We're hearing these noises. We're trying to match them back to phonemes against our dictionaries and language models to say, was that an actual thing? No, it wasn't, it wasn't, it wasn't. And then you say a word, and it gets the right word. But you might sometimes see that start word timing is a bit out because it kind of thought the music was part of the word. It wasn't, but at that point it's doing that. That's something that's, again, under active development to improve that. So although the word is correct, you might sometimes see the start time is a bit out. And that's something that's being looked at right now for development. But usually it's okay in background noise. And usually if you have like a call center environment where it's just me talking, but you can hear as a caller that behind me you can hear 6 other agents quite quietly, but they are there. They shouldn't be, because the volume levels are so different, it shouldn't pick up the background speakers. If you're talking on the phone to someone else and someone else in your family is right next to you talking to you as well, it may pick up both because the microphone does. And there's not much we can do with that because all Transcribe will see is a single stream of 2 people talking over each other. And it will probably transcribe them both. So if you have a directional microphone or you're just using a headset on your phone when dialing in, that really doesn't happen because the microphone is so directed to you, hopefully.
Andrew, I'm just wondering, is there a possibility that when there is background music, that what the speaker is saying, and especially if it is in a call center, and the background music are coming in 2 different channels, and we can use maybe the channel differentiation feature in Transcribe
to at least experiment with something like that? Have you seen such
I think
situations?
in the contact center, probably not, because it's not going to be on the caller side. It's just going to be on the agent side.
Yeah.
So you only have one thing. But it generally ignores it, so it doesn't really come up in the transcript. Again, you just got that slight misalignment of start times, perhaps. But otherwise, it does a good job on ignoring that sort of thing. Bad examples we have, of course, is people at train stations phoning into contact centers when the station tannoy announcement goes off right next to them. Again, we can't take that out. It's going to be in the microphone stream that goes to to transcribe, and that's what you're going to get. Not the person speaking, someone shouting that the train on platform 6 is 20 minutes late. And that's what's going to come across instead. So we have multiple speakers going down that one channel. We will just try and transcribe everything we hear, because we don't actually know it's two speakers necessarily on a contact center call. If it was an audio file, of course, obviously just any sort of broadcast TV program, there are multiple speakers. And so transcribe can, if you tell it in advance to expect 6 speakers, 8 speakers, it will be aware that it's looking for 6 or 8 different tones of voice, different ways of speaking, and it can tell that we have speaker 1, 2, 3, 4, 5. And it will tag them with that label. And so through the transcript, you can see this is speaker 1 on, this is speaker 2. You'll see a little bit of overlap as one talks over the other one, but it will do a good job at actually tagging who's actually saying what. But telephone calls, it really is, their channel is, or one channel is the customer, one channel is the agent, and we're expecting us one-to-one mapping.
And is it able to distinguish between a human-generated voice versus non-human? So, Alexa, Siri, is there any distinction there?
Unfortunately not. It's got no real metadata to make that decision, because all it's seeing is the same phonemes coming in the audio stream. Whether it's me saying it, Alexa or Siri, it doesn't really matter. It will still say the same words. And in fact, I think one of the voices you had in your video was actually Polly doing the little audio playback. Right. And transcribe would quite happily take that and transcribe it. We've got no other information to say this is a bot, or this is someone saying please hold, or something like that, or an automatic IVR message. As far as we're concerned, it's just a stream of audio words. We can't tell the difference.
And to that point, our services, all our services, including transcribe, are always improving, and customer feedback is so important. So I would like to talk to you after this Q&A session, just to understand your use case, having Alexa or Siri in the background.
Okay, I think that's it for questions. So if there's no more questions, thank you very much for your time. Hope that was useful and educational. Any other questions, just catch us outside the session, and we're happy to answer them. Thanks again.
Thank you all.